Okay, let's take a look at number 2. Let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x, and g of x equals x to the fourth minus 6.5x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs of f and g shown in the figure above. Find the sum of the areas of the region R and S. Okay, so hopefully when you look at this, you quickly realize this graph right here is essentially we're just trying to figure out the area in between two graphs, which is just top minus bottom. Now the trick in this question is that if you look closely, you'll notice that one graph cuts through here like such, and the other one goes like such. So what you'll notice is that at some point here in green, that I'm marking in green here, there is some sort of like switching going on where the top graph is no longer the top and the bottom is no longer the bottom. So you have to split up your integral into two parts. What you should be thinking about is section 36, page 209. We are just applying this at the bottom here, top minus bottom functions, right? So that's all we're doing, but we need to figure out what graphs what. We have to figure out, and we have to figure out the point of intersection. And then if we just do top minus bottom, we will figure out how much area is in each region. So if we just integrate the top from the integration of the bottom. So let's do that. So the first thing you're going to notice here is that I typed in the functions here. Actually, I had them already typed in, right? And then we looked to see the points of intersection. Your graph may look different. This one here is their 2, 4 that they gave you. So you didn't need to check that. I actually did just to make sure, and it is 2, 4. But the new point of intersection that is particularly of interest is 1.0328319, comma 2.4011081. Okay, so this is the point of interest that I care about in the beginning, this green part right here, okay, which is now apparently orange. Okay, so once we get that value, all we got to do is we just have to integrate it. So let's go back to this here. So what am I actually doing? Well, all I'm really doing is I'm going to integrate from 0 to 1.032832. I'm just going to type it all in just to be safe. And I'm just going to use g of x and f of x. So what we find out here is that the red one is g of x and the blue one is f of x. So it starts off g of x minus f of x. dx. And then we're going to add from 1.03282 to 2, what you'll notice is that they switch. So it's going to be f of x minus g of x dx. So these are our two functions that we're looking at here. And all that's left now is to compute this. So when we compute this, you can see here, here's for the first one, here's for the second one. They're very long, so again, just like in the previous question, I put the first half here and the second half here, the first half here and the second half here. So but if you do that, you end up getting 0.9997 and 1.00691. I think 692, I guess, if I round. So note also that I am putting in the exact value. I'm not going to play around with this, so I'll round at the very end, but I won't round till the very end. And in the end, we just add them up. You end up getting this number here, 2.004, and that's our answer. That's the area. So all we're doing here really is calculating the area above and below the curve. So please, again, if you're having issues, you want to refer back to the notes on section 36, page 209. Just follow through those notes, and you'll be perfectly fine. All right. Hopefully that was okay, and I'll see you all in the next video.